There is one world that humanity refused to visit only once. We returned. Again. And again. Every mission believed it would reveal Saturn's greatest secret. Instead, every mission discovered an even greater mystery. Oceans beneath frozen worlds. Storms larger than planets. Rings that may disappear before our eyes. For more than 60 years, humanity has been trying to understand Saturn. And our journey is only just beginning. In September 1979, a small, dish-shaped spacecraft plunged into the uncharted realm of the outer solar system. Its name was Pioneer 11. It had taken 6 years to travel over 1 billion kilometers. By the time Pioneer reached Saturn, its electronics were aging. Its signals took over 80 minutes to reach Earth, and its navigation was largely a leap into the dark. NASA was taking an immense risk. Before Pioneer 11, scientists did not know if the space surrounding Saturn was filled with microscopic debris. A particle no larger than a grain of sand, striking a spacecraft at 20 kilometers per second, could vaporize its electronics instantly. Engineers held their breath. Pioneer was sent directly through the ring plane, acting as a scout, a sacrificial probe for the future missions that followed. On September 1st, 1979, Pioneer 11 crossed the ring plane. It survived. It passed just 21,000 kilometers above Saturn's cloud tops. For the first time in human history, an artificial object looked down upon the Titan of the solar system. The images returned were grainy, low-resolution pixel arrays by modern standards. Yet, they were revolutionary. Pioneer 11 discovered a previously unknown ring, the F ring. It measured Saturn's powerful magnetic field, confirmed that the planet was composed primarily of liquid hydrogen and helium, and revealed that Saturn radiated more heat than it received from the Sun. Most importantly, Pioneer measured the temperature of Saturn's giant moon, Titan, revealing it to be an ultra-cold world shrouded in a thick, dense atmosphere. Pioneer proved it could be done. The outer solar system was not an impenetrable wall. Now, humanity wanted more. Just 14 months after Pioneer's flight, a pair of sophisticated robotic explorers arrived to fundamentally redefine our understanding of the cosmos. Voyager 1 and Voyager 2. Where Pioneer took snapshots, the Voyagers carried high-resolution Vidicon cameras, infrared spectrometers, and advanced cosmic ray detectors. They did not merely pass by Saturn. They conducted a scientific blitzkrieg. When Voyager 1 swept past Saturn in November 1980, it shattered centuries of astronomical theory in a matter of hours. Astronomers expected Saturn's rings to be a few dozen continuous bands of ice. Instead, Voyager revealed that the rings were composed of tens of thousands of individual ringlets, stretching out like the fine grooves of a giant vinyl record. The rings were dynamic, alive, governed by complex gravitational dances with miniature shepherd moons that sculpted their edges. Voyager saw dark, phantom-like spokes sweeping across the rings, created by levitating dust particles interacting with Saturn's magnetic field. To achieve this incredible data, NASA had to make a dramatic sacrifice. Engineers intentionally directed Voyager 1 on a close flyby of Titan, Saturn's largest moon. The trajectory allowed Voyager to measure Titan's atmospheric density and composition, but the gravity of Titan flung Voyager 1 out of the planetary plane forever, ending its tour of the planets. 9 months later, Voyager 2 arrived to pick up the mantle. It captured high-speed movies of Saturn's violent atmospheric storms, measuring winds exceeding 1,500 kilometers per hour at the equator. It photographed Saturn's icy moons, revealing Mimas with its colossal crater, and Enceladus with a bright, unblemished surface that hinted at recent geological activity. In the span of 2 years, Saturn was transformed. It was no longer just a planet. It was a complex, living planetary system, a miniature solar system unto itself. Voyager left Saturn forever, but it left behind questions no flyby could answer. To truly understand Saturn, a brief visit of a few days was no longer enough. We had to go back, and this time, we had to stay. A flyby spacecraft is a runner taking a photograph as it sprints past a landmark. An orbiter is a resident that moves in, sets up a home, and watches the seasons change. To build a mission capable of orbiting Saturn, humanity could not act alone. It required the greatest international space collaboration in history. NASA, the European Space Agency, and the Italian Space Agency joined forces to design a flagship probe of unprecedented scale. Its destination, Saturn. Its name, Cassini-Huygens. It was the size of a school bus, weighing over 6 tons when fueled. It carried 12 state-of-the-art scientific instruments on the main orbiter and a detached atmospheric probe, Huygens, designed by European engineers to do what was once thought impossible: land on the surface of Titan. The engineering philosophy behind Cassini was fundamentally different from previous missions. Because Saturn lies nearly 1.4 billion kilometers from the Sun, solar panels were useless. Cassini relied on the decay of plutonium-238 to power its electronics across a planned multi-year duration. It was engineered to endure extreme temperature swings, intense radiation, and total autonomy, executing complex maneuvers when light speed delays made real-time control from Earth impossible. On October 15, 1997, Cassini ignited the night sky above Cape Canaveral.
6 complete. Roger.
It embarked on a 7-year, 4 billion kilometer journey through the solar system. It looped past Venus twice, swung by Earth, and skimmed past Jupiter, gathering speed with every gravity assist.
Proceed with the countdown.
Launch sequence started.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
7 years of silent drifting through the dark void. 7 years of waiting. Engineers on Earth aged. Children grew up. All while a machine made of titanium, aluminum, and gold foil silently closed the distance to the ringed giant. On July 1, 2004, Cassini reached its destination. To enter orbit, the spacecraft had to fire its main engine for 96 minutes, plunging directly through the gap between Saturn's F and G rings. A single miscalculation meant Cassini would either bounce off Saturn's atmospheric gravity or be destroyed by ring particles. The burn was flawless. Cassini was captured by Saturn's gravitational embrace. Humanity had arrived. And for the next 13 years, Cassini would live with Saturn. Over more than 200 orbits, Cassini watched Saturn change. It witnessed a full Saturnian season, a period that lasts nearly 7 Earth years. It saw the shadow of the rings stretch across the northern hemisphere during winter, then shrink to a razor-thin line during equinox, when the sun hit the ring plane directly edge-on. At Saturn's North Pole, Cassini unmasked one of the most bizarre atmospheric structures in the universe, the hexagon. A jet stream churning at 300 kilometers per hour folded into a rigid, perfectly geometric, six-sided pattern wider than planet Earth. Inside this atmospheric cage raged a massive polar vortex, a tempest resembling a giant crimson rose. In late 2010, Cassini captured a once-in-a-generation event. A massive white eruption began in the northern hemisphere. Within months, the storm grew exponentially, stretching completely around the planet until its head swallowed its own tail. It was a planet-girdling superstorm, venting thunderheads hundreds of kilometers deep into the atmosphere, generating lightning flashes thousands of times more powerful than anything seen on Earth. Cassini revealed that the rings were not flat, lifeless sheets of ice. They were dynamic, churning ecosystems. Tiny embedded moonlets, like Daphnis, pulled ring particles up and out of the plane, casting towering shadows a kilometer high across the shimmering ice fields. Cassini showed us Saturn not as a static painting, but as a turbulent, breathing engine of physics. Yet, the true genius of the Cassini mission lay not in the planet itself, but in its moons. On January 14, 2005, the European Huygens probe separated from Cassini and fell toward Titan. For 2 hours, Huygens drifted through Titan's thick nitrogen atmosphere under a parachute. As the fog cleared, instruments revealed a landscape hauntingly familiar, yet alien beyond imagination. At minus 180 degrees Celsius, methane takes the place of water. It forms clouds, falls as rain, flows down icy rivers, and fills vast polar lakes of liquid ethane and methane. Titan was an inverted Earth, a prebiotic chemical laboratory frozen in time, possessing rich organic chemistry floating under an orange-tinted sky. If Titan shocked the world, a tiny moon measuring barely 500 kilometers across would change astrobiology forever. Enceladus. In 2005, Cassini flew past Enceladus and captured an astonishing sight against the dark backdrop of space. Towering geysers were shooting thousands of kilometers into space from fractures at the moon's south pole, cracks dubbed the Tiger Stripes. Cassini was reprogrammed to dive straight through these active plumes. Its instruments smelled the spray. It detected liquid water ice, simple organic molecules, salts, carbon dioxide, and molecular hydrogen. Cassini had confirmed what lay beneath Enceladus's frozen crust: a global subsurface ocean of liquid water, kept warm by tidal friction from Saturn's gravity, reacting with a rocky core through hydrothermal vents. Here, in the deep darkness of the outer solar system, heated by planetary tidal forces, was an environment with every ingredient necessary for life as we know it. Water, energy, organic molecules. Saturn had become something entirely different. It wasn't one world. It was many. By 2017, Cassini had spent 13 years in orbit. Its fuel reserves were nearly exhausted. NASA scientists faced a critical, heartbreaking dilemma. If Cassini ran out of fuel, controllers would lose command of the craft. Left drifting, it would eventually collide with one of Saturn's moons. If Cassini crashed into Enceladus or Titan, microbes from Earth that might have survived aboard the spacecraft could contaminate these pristine, potentially inhabited worlds. Under the strict laws of planetary protection, Cassini could not be allowed to become a space hazard. It had to be destroyed. NASA chose to give Cassini a warrior's death, the grand finale. 22 daring dives through the unexplored narrow gap between Saturn and its innermost rings. It was a region no spacecraft had ever entered, a final high-stakes scientific gambit. With each pass, Cassini collected unprecedented data on Saturn's gravity, its precise magnetic field alignment, and the exact mass of its rings. On September 15, 2017, Cassini turned its high-gain antenna toward Earth for the last time. It entered Saturn's upper atmosphere at over 113,000 kilometers per hour. Its small attitude control thrusters fired at 100% capacity, fighting furiously to keep the antenna pointed at Earth, to transmit every final byte of data back home. Inside the atmosphere, friction turned the spacecraft red-hot. Within seconds, Cassini melted, vaporizing into a bright streak of light, becoming a literal part of the planet it had spent 13 years studying. The story of Saturn did not burn up in the clouds on that September morning. Even now, The answers Cassini sent back are inspiring the next bold stride into the unknown. In the late 2020s, NASA will launch Dragonfly, a revolutionary mission returning to Titan. Dragonfly is a rotorcraft lander, a heavy drone capable of flying between dozens of different locations across Titan's surface. It will search for chemical biosignatures, taking flight through an alien sky on a moon where gravity is low and the air is dense enough for a human to fly with artificial wings. And concept studies are already envisioning future return missions to Enceladus. Probes designed to skim through the plumes, catch ice grains, and answer the ultimate question. Are we alone in the dark? Pioneer opened the door. Voyager showed us the way. Cassini changed everything. Dragonfly is only the next chapter. Saturn is no longer a distant light in the night sky. It has become a destination, a laboratory. Perhaps, one day, even a second home for discovery. Because every generation leaves one mission behind for the next to finish.